Hi students, in this video we will discuss about binary search using recursion. So first let us discuss what is searching. What is searching? Checking whether the given element is present or not is known as searching. Then what is binary search? So in the previous video we discussed about linear search. In linear search, elements are searched sequentially or continuously one after the other. Whereas in binary search, so before searching, all the elements must be arranged in sorted order. Whereas in binary search, what happens? This is similar to searching for a page number in textbook. That is, if you want to open a page number or page number 700 in a 1000 pages textbook. So whenever we open, let us assume that it has opened 500. Then what we could do? Our search page is 700. 700 equal to 500? No. So 700 is greater than 500. So we'll search in the right half. So left half we will be discarding. In this way, in every iteration, the list will be divided into two parts. Now, the same thing we are performing using recursion. What is recursion? A function calling itself, we call it as recursion. Okay, in this technique, the search element is compared with the middle element. If it is equal, we will stop. If it is greater than, we will search in the right half. Otherwise, we will search in the left half. Now, let us consider binary search using recursion. Now, let us take this part. How to write using recursion. First, let us assume that void binary search. So int a of, it is an array. Int L represents the left part. Int R represents the rightmost element's index, and the search element is key. Key is the search element, the element what we want to search. Now here, first our comparison should be if left less than or equal to right. Same thing we have written in our without recursion binary search also in a normal function. So if left less than or equal to right, then only we can perform the search operation. If left less than or equal to right, if this is false, meaning the element not found. So directly you can write here return 0 or return -1. That is the search element not found, you can return. Now suppose here if left less than or equal to right, then check for the middle element. What is middle element? Middle equal to left plus right by 2. Now if compare key element equals to a of mid. If key element equals to a of mid, directly you can write return mid. That is index of that particular element will be returned. That is where the element is available, that will be returned. So if it is not equal to a of mid, then what will be the position? If not equal to a of mid, then we should check for else if key element is greater than a of mid or not. If the key element or the search element is greater than. If it is greater than, tell me where it will be available. It will be available in the right half. Okay. Now let us trace up to here, then I will explain you. So initially L value, while calling the function, we will call with the index number. A is the complete array, L is the index of the first element, R is the index of the last element, that is n-1, and the search element. Let us assume that I want to search for an element called 80 is available in this list or not, I want to check. So what we need to do here, now there are 10 elements in the list, so L value is 0 and R value is 9 in the first iteration. So 0 less than or equal to 9, S enters into this block. 0 plus 9, 9 by 2, 4. That is mid is pointing to index number 4. Now mid is at index number 4. Now key element is 80. A of mid is 50. 80 equal to 50, false. Then it goes to the else part. 80 greater than 50, S. Now if S, what happens here? So the element will be available only in the right half. Initially left is here and right is here. Now the elements in the list are, now for us the elements in the list are, right. Now what are the elements in the list available? 60, 70, 80, 90, 100. Now as 80 is greater than 50, the element, if available, the element will be available only in the right side, that is 60, 70, 80, 90, 100. So R is already pointing to the index number last element. Now L should point to the next element, that is mid plus 1. How to point here? Mid plus 1. The index numbers are same, there is no change in the index numbers, that is 5, 6, 7, 8, 9. There is no change in the index numbers. So mid should, that is left should point to mid plus 1th element. So here while calling, our function call will be in this way. Our function call will be, so binary search of A means complete array, A comma mid plus 1 comma R. Mid plus 1 comma R comma key. We will call in this way. So here what happens? A means complete array. Mid plus 1 means mid value is 4. 4 plus 1, 5. Again the function will be called by passing the value. So L value will be 5 now. R right value will be 9. That is the index of the last element. Now again, suppose if it is less than the middle element, if it is greater than the middle element, it will be called in this way. If it is less than the middle element, else binary search of A comma L comma mid minus 1 comma key. Mid minus 1, that is R value will be mid minus 1 value, that is R will come to left point. Now let us trace with 5 and 9. So 5 less than or equal to 9, yes. 5 plus 9, 14. 14 by 2, 7. 7 will be stored in mid. So key element is 80. A of 7 is 80. So now here both are matching. So mid element is 6. Then return M. M value is 7. This 7 will be returned back to the caller. This is searching for an element using binary search. Now let us trace the program. So using binary search, if you want to call, so we need to call in this way. Here binary search of, so the return type should be int binary search of int. So what are the parameters we need to pass? Int left comma right comma key. Then similarly accept n elements from the user. Then function call should be binary search of int 0 comma n minus 1 comma key. Then in the function definition you need to write in this way. So the return type is integer. Binary search of int L comma int R comma, then here just declare one variable mid, int mid. Now here instead of while we will use here if. If left less than or equal to right, enter into this block mid equal to left plus right by 2. Then if a key equal to A of mid, so directly what we can write here, return mid, return mid, return mid, index of mid will be returned. Now if key is greater than A of mid, so again we need to call the function, that is binary search of A comma L comma, sorry, greater than, then mid plus 1 comma R comma key. Otherwise else if it is less than, then we need to call binary search of A comma L comma mid minus 1 comma key. It is called in this way. Then after, if it comes out of, when the condition becomes false, return minus 1. This minus 1 represents that not found. Now here that function will return the value the returned value you need to store in one variable. So take one variable called I. If I not equal to -1, then display the message printf search element found. Otherwise display else search element not found. Search element not found. Save this program. Now check this logic is very important. Now let me trace and show you the program. So there are some errors. If found equal to 1, this is not required, right? So enter the number of elements 10, then enter the first element 10, second element 20, third element 30, fourth element 40, fifth element 50, sixth element 60, seventh element 70, eighth element 80, ninth element 90, and the 10th element 100. Now accept the element key search element. I want to search for an element called 80. So here the function is called. Now here you can observe what is the L value and R value and all. Here let us take, so L, then R, then key, then A of mid. That is which element we want to search. Now if you observe, L value is 0, R value is 9. 0 less than 9, S mid is 4. That is A of mid is 50. 80 equal to 50, false. Then here key element is 80, A of mid is 50, then greater. So again the same function will be called. Now L value is 5, R value is 9. Now 5 less than or equal to 9, S mid equal to 7. Then key equal to A of mid, S, return mid. This mid will be returned back to the caller and it will be displayed onto the screen. That is search element 80 not found, it is displaying. Okay, some problem, we'll rectify that problem. So mid, if I not equal to -1, search element found. Then if it equal to -1, then it displays that problem. Okay, I will execute and share that link. I will share the link. What is the problem? That link I will share you. Okay, thank you for watching.